Hey, you guys, welcome back. Let's go through this similar figure practice that we did earlier in class today. So in case you missed a number or weren't quite sure how we did any of these problems, let's go through it together. All right, this first one. All of these problems say to find the missing side lengths in each of these similar figures. So we told you they're similar figures, so we're going to go and find the missing length over here. So this one we're missing this right here. Let's go and find that. Now the way we're going to do this, I'll leave this up here. We are going to go and set up a proportion on all of these. Now a proportion is just two ratios that are set equal to each other. Remember, a ratio is like 2 to 1 or 5 to 10 or 8 to 3. A ratio is like that. And this is how we set it up. Two ratios set equal to each other. So I'll have a number up top, down below, up top and down below, and we just have them equal to each other. So let's go and look at this first one. So, oh, actually, one more thing about the proportion. We're going to keep it in this format, new over old. Now, I'm going to have that on both sides of the equal sign. The most important part is that it's kind of like when we talked about things being on the same shelf. If we have these proportions set up, I want the new to be on the same shelf. I want the old to be on the same shelf. Now, if you flipped it around and did old over new is equal to old over new, you would still get the same exact answer. All that matters is that the old is on the same shelf and the new is on the same shelf. Okay, that's the most important part. So just for consistency's sake, I'm just going to do this top one because that's what we did all day in class today. All right, new over old equals new over old. So let's go and set one up. Let's see, x, and whenever I find the new versus the old, I'm looking for corresponding sides. And corresponding just means the same location on the other figure. So x looks like the same location in the other figure is 6. So we have x and 6. Now, I'm going to put the new over the old. And in case you've forgotten, the new one is always on the right and the old one's always on the left. Unless we tell you different, but we haven't told you differently here. Not in this problem, okay? So let's go and put new over old. 6 over x. And then let's go and find another set of corresponding sides. Now, I have an 8 right here, but you're going to notice down here, I don't have a corresponding side filled in right there, so I can't use the 8. I don't know what the corresponding side is. I have 10 right here. That corresponds with 25. Great, that's corresponding. So I'm going to have 10 on my new, 25 on the old. I'll go through, cross multiply and divide. 6 times 25 is 150. X times 10 is 10x. Divide both sides by 10. And x is equal to 15. And now kids, all day today we're asking, what if they put the proportion on the other side? So notice how I have 6 over x on the left side of this proportion. What if I moved that around and had 10 over 25 on the left side and 6 over x on the right side? Let's go and solve it just to see what happens. I'll cross multiply and divide. 10 times x equals 10x. 6 times 25 is 150. And then I'm going to divide both sides by 10. Both sides by 10. X equals 15. Oh, look, we get the same exact answer. That's because whenever we're dealing with a proportion, we're talking about two things that are equal to each other. So it doesn't matter which side of the equal sign they're on. They're equal to each other, so you can flip them around, and it's just fine. As long as we have the new on the same shelf and the bottom on the same shelf, we're good to go. Let's look at the next one. This one, let's go and see what we have that corresponds. Now, this is a little different because this triangle right here, the new one, is in a different position than the old one. All right? That means we just have to be really careful about assigning corresponding sides. So these actually are labeled for you. So this is triangle ABC. And if you remember, the first triangle is always labeled alphabetically. All right, ABC. This symbol right here means similar to. And then ABC is similar to X, Y, Z. Now what's really great about this is that no matter what position these triangles are oriented in, we can always tell what corresponds because side AB is going to correspond to side XY. Notice they're in the same positions when we name them. So AB is right here. It's 50. It's going to correspond to XY. And that is this one right here, which is X. So let's see. What else do we have? We have CB. That's 40. CB is going to correspond to ZY. And that's this one right here. So 40 and 20. So let's go and put the new over old and set it equal to another new over old. X is on the new, and it corresponds with 50. So x over 50 is equal to 20 is on the new, and it corresponds to 40 on the old. Let's cross multiply and divide. 40 times x is 40x. 20 times 50 is 1,000. We'll divide both sides by 40, and x is equal to 25. There we go. Let's look at the next one. Another missing side, and this time we're missing not just one because we're missing an x, we're missing a y over here, an x and a y. So we can only do one at a time, right? Let's go and see what we know that corresponds. So you can look at the order of the letters in the naming of the triangles, or another way you could see is here's my right angle. Directly across from the right angle is x. Directly across from the right angle over here is 34. So x and 34 correspond. So x over 34, new over old. And then let's see what else I have. I can't use the y over here. I can only have one variable in this proportion to solve for. I can't solve if there are two variables. So I'm not going to do the y right now. I have 15. Let's see, what does that correspond to? It's between z and y, so it must correspond to between whatever is between b and c, and that's this one right here. Sometimes it's hard to visually flip it in your mind, so having these named and labeled is really helpful. So 15 over 30, new over old. Let's go and cross multiply and divide. It's kind of hard to do that on this pen, on this tablet, but looks okay. 30 times x equals 30x. 15 times 34, I don't know it. Let me grab our best friend, the calculator. 15 times 34, and we get 510. There we go, 510. We'll divide both sides by 30, X equals 510 divided by 30 is 17. Perfect. X is equal to 17. Now, let's go and find y. So y is between z and x. Let's see, we got z and x, so it must correspond to whatever is between c and a. C and a, that's this one right here. So y corresponds to 16. Let's do our new over old, y over 16. And then I can't use the x because, again, I can't have two variables in this proportion to solve for it. So I'm going to use the 15, and we already found out that 15 corresponds to the 30. So 15 over 30. I'm going to cross multiply. 30 times y is 30y. 15 times 16, let me grab my calculator. I don't know that one. That's 240. I'll divide them both by 30, and y is equal to 8. There we go. Let's do the next one. Let's see. Let's go and see what we're missing. Oh, we need to look for x, and we need to look for y as well. So we have two variables missing again. Let's go and find x. So x, let's see what it corresponds to. It's between a and c. So if it's between a and c, it must correspond to whatever is between x and z. All right, same spot in the naming, okay? So x and z is right here. So it corresponds to the 13. So we're going to have 13 over x. That's my new over the old. And then, let's see, I can't use the y, so I'm going to use the 14.4. It's between a and b. So if it's between a and b, that must correspond to x and y right here. So 14.4 corresponds to 12. 12 over 14.4. So 12 times x gives us 12x. 13 times 14.4. Is that 13? Yeah, 13 times 14.4 gives us 187.2. I'll divide them both by 12, divide by 12, and x is equal to 15.6. Excellent. Pen acts up sometimes. 15.6 is what that is. All right, let's look at y. So y, we don't know it. It corresponds to whatever is between b and c. B and c corresponds to y and z. Y and z is right here. So y and 5. We'll do the new over old. 5 over y. And we know 14.4 I have to use because I can't use the x. So 14.4 and 12, we already found those correspond. I'll cross multiply. 12 times y gives us 12y. 14.4 times 5, 14.4 times 5. gives us 72. I'll divide both by 12. And I end up with y equals 6. That's a 6. There we go. All right, let me give that an erase so I can scroll down. There we go. Look at 5 and 6. Now these look a little different just because the triangles are inside each other, all right? Because this small triangle is placed inside the larger triangle. And sometimes that looks a little confusing, but we just have to be able to picture triangle JKL and triangle GKH, all right? So if you want to draw it separately, you absolutely could. So I'll just draw the smaller triangle over here, and I'll go fill it in. So we'd have GKH. Let's see, G to K, that's 6. G to H, that's X, we don't know it. And then I'm just going to mark this out, all right, because I've redrawn my triangle. And then K to J, J to K, that's actually 6 plus 4, which is 10. So I have 10 for this side, I have 15 for this side, and then I have X and 6. I can go set up a proportion now. We're going to new over old. We'll do the X, and it corresponds with 15, so X over 15 is equal to 6, and that's in the same spot as 10, all right? So we have 6 over 10. And remember, all we did was just add the 6 and the 4, because we're talking about the whole length of this side, okay? So we added them up and got 10. I'll cross multiply and divide. I get 10x equals 6 times 15. Gets 90. I'll divide both sides by 10, and I'm left with x equals 9. Excellent. Let's look at this last one. Again, the same type of situation, but now we're looking for x and y. So you know what? I'm just going to redraw the smaller one just so we can see it over here. This is 5. This is 3. This is 4. And then I'm going to mark that out right here. All right. The 3 and 4 don't actually matter because what this means is that side D to A is actually the length of y. And now side A to E is actually the length of x. All right? So I'm going to mark out all these pieces that can throw me off. All right? Here's my triangle y, x, and 12.5. Now we can set up a proportion. All right? And again, it doesn't actually matter which one you put on top, new or the old one, as long as we have them on the same shelf. All right? So I'm going to consider the small one the new one. All right? Let's see. 4, that corresponds to x. I'll do 4 over x is equal to, let's pick another set that has 2 numbers, 5 and 12.5. I'm not going to use the y because I can only have one variable here in this proportion. 5 times 5 over 12.5. Notice I have 4 and 5 both on the top, both from the new one, x and 12.5 both on the bottom. Let's cross multiply. 5 times x gives me 5x. 4 times 12.5 gives me 50. I'll divide them both by 5, and x is equal to 10. Now let's do the last set. So I need to go and figure out what y is. Y corresponds to 3. So I'm going to have a new over old. I'll have 3 over y is equal to, I can't use anything with the x because I need one variable here, not 2. So I'm going to use 12.5 and 5 again because those correspond. Same spot on different figures. So new over old. And then let's cross multiply and divide. 5 times y gives me 5y. 3 times 12.5 gives us 37.5. I'll divide both sides by 5. And I'm left with 7.5. So y is equal to 7.5. All right, so that's how we set up proportions to find missing sides, okay? Again, to recap, it's new over old equals new over old, okay? As long as you have the new on the same shelf and the old on the same shelf, that's all that matters, okay? Whether it goes on the top or bottom is not important as long as they're on the same shelf, all right? So thank you guys for sticking around for the whole video, and I will see you guys in class tomorrow.